Hello, I'm Mark Opry, and we're going to be doing Maxum 2 instructional videos, and this will be for the students to come in and take tests after we get through going through calibrations, retention times, all of that type of stuff, groups, integration events, looking at our valves, timing, stuff like that. And we're going to go into all of that stuff, and then whenever y'all come back after the coronavirus, then we will take tests on everything. Right now we have our analyzer slowly but surely warming up right next to us here. We are going to discuss the software of GCP, GC Portal. All right, so to begin with, the analyzer I just kicked on, we have to have carrier gas and air to it. We have both of those going. Ta-da! Maxum 2. Okay, everybody, let me introduce you to the Maxum 2. This is our electronics enclosure. This is, if you're Hispanic, this is a magazine, but if you're not, this is your mezzanine. Inside of your mezzanine, a lot of people just throw trash in here and stuff like that. Throw your flow meter. Here's your flow diagram of what's going on in the analyzer. If you have a flame ionization detector or a flame photometric detector, they would be mounted inside of here. Instead, this is where our tubes are coming through, which are going down to our valves down here. We have two apps. We have app 1, app 2, and they're identical. And basically on these two apps, it's still two independent GCs in those apps. We're gonna have, so this is your right side, this is your left side, makes very common sense. This is your side on this side, and this is your side on this side. So this is your furthest right. So the set of thermistor beads that's in this side, that's going to be like this, is going to be the right. And then this set that's going to be over here is going to be the right-left. In this case, this is going to be left-right, and this is going to be left-left. In each set of thermistor beads, I guess we need to go into thermal conductivity detector, but we're not doing that right now. We're just doing Maxum specific. You're going to have your reference, and then bead 1, 2, 3, which is typically pre-cut, main, backflush. Reference, everybody compares themselves to reference, pre-cut, main, backflush. Say it again, say it again, say it again. So, that being said, let's take a look at our electronics up here and see exactly what we got going on. It's very, very mad because it just woke up. It needs to get its oven up to temperature. I don't know if the HMI is going to play with me today or not. It's not happy, but we can make it work off the computer very easily. Again, this is HMI. They used to be called MMIs, man-machine interface, but no, we can't have that. No. So now it's a HMI, human-machine interface. Syscon motherboard. Syscon motherboard. This is where all of your data is stored as far as your program and everything like this. Is a computer. This is a computer board. This is where we do our communications part. This is where your analog inputs, analog outputs, and your digital inputs will come into play right here. That right there is a pressure switch. That pressure switch is coming off over here. If that pressure switch gets low, it'll trip that guy, and then it'll shut everything down on us. So we have to either have enough pressure for that guy to be happy, or you just jump that out, which I did not tell you to jump that out. Okay. Take a lookie. Syscon. Got a little battery, so if you lose power, it's going to save everything that you've stored in there, and you save it to its flash memory. Everybody's looking good. Green lights are good. Green lights are good. So let's get everybody back in there. Syscon. Everybody got that? Power Entry Control Module. PECM, Power Entry Control Module. That is you. That's your distribution of power coming in. So there's your 120 coming in, going through, a whole bunch of fuses and everything. Your over temp is right. Your over temp protection is these guys right here for your oven over temp protection. If you ever have to change that card out, you're going to have to pull these off of your old card and put it on the new, because the new card doesn't come with them. How do I know that? Trust me. It whooped me one time. So learn from my mistakes. Actually, it wasn't a mistake, I just didn't tell me. These back here are your relays for controlling the temperature of the oven. You have an over temp relay, and it even says OT relay right back there. Let me see if I can. OT relay. Over temp and control. These are our control relays that are going to be doing for our oven temperature. We need to get up to 140 F, which is 60 degrees Celsius. Say that over and over and over again, because remember that. And also 40 degrees F is 4 degrees Celsius. Just memorize that. All right, that being said, here are our DPMs, Detector Personality Module. Detector Personality Module. We know that we are dealing with TCDs, because these are the wires coming off of our thermistor beads. Our little thermistor beads are coming out of these guys. So the thermistor beads come up to here to our Detector Personality Modules. There's one for that side, there's one for that side. That goes down into here. We're wanting this oven to warm up. This one's warming up too, but we don't really need it to warm up, so let's go ahead and kill that. And then finally, there's your solenoid valves for firing air down there. And this is our, these are our EPCs, electronic pressure controllers, EPCs. They're daisy chain. And you have to have these jumpers that are different colors so that it knows who it is. Or otherwise, the new ones come with switches and you have to know binary code, which you should know that by now. So, here we go. Let's talk about logging on to... Okay, so let's talk about logging on and getting to communicate with our analyzer. All right, so what we're going to want to do is you're going to have two icons on your desktop. You're going to have gas chromatograph pH portal analyzer view, and then you're going to have your network view. We want to use the network view, all right? Network view. Network view, and we're waiting for this guy to start talking to this guy, which should happen. Super 555 is your password. Okay, so again, like I was saying, you're going to have app 1 and app 2 for the analyzer. Let's go into app 1, which is that side of the analyzer. And then let's go, you know what we're going to do? Let's go ahead and do this. Let's pull up our HMI. You see where it's saying start HMI? We're going to do start HMI right here. And now that that's pulled up, what we're going to want to do is say temperature, which is this guy right here, and then we're going to say disable. So the left oven is disabled because we got it open, so there's no need for it to warm up. That's app 1. If we look at app 2, we want this one warming up. So you have currently 48.4, 48.6 temperature is rising, set point of 60, which is 140 F, and this is how much wattage we're putting out. We're putting out like 100. And so that's going to get the temperature up there, and then it's going to line out. All right, so we were working on getting this guy, and we're slowly but surely getting up to our 60. So let's go home. And all you got to do to get home is come up here and hit the little home. Then we're going to say alarms. And never read all this stuff. You just hit clear all and see what comes back. And I'm pretty sure what's going to come back is temperature. It's not going to be happy. There you go. Deviation exceeded on temperature controller. Deviation exceeded on temperature controller. And it's just in warning now. It's just yellow, so it's just a little bit mad. It's not super mad, it's just a little bit mad. And we killed the temperature for that other oven. So that's app 1, then this is app 2, and app 2 is identical. App 2 is identical to this one. The only difference is over here. That actually, yeah. While we're waiting for that to warm up, while we're waiting for that guy to warm up, there's your thermistor beads. Underneath, behind those wires, where they connect up, is your thermistor beads. Those are 30K each. 30K, 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 30K. All right? And you're going to be looking at so that one is going to be right reference, bead 1, bead 2, bead 3. Left reference, 1, 2, 3. All right? 1, 2, 3, pre-cut main back flush. Reference. Reference, pre-cut main back flush. Okay? Okay. I need tape. We are letting our analyzer get to a stable position, and now we're going to purge cow gas through our valves. I have a bottle. I have a cow bottle here, and I've turned it on, and we are going up into the analyzer, coming back out, and I know that I have good cow gas flow because I have bubbles. So we know that we have a good cow gas flow. Now, what is our cow gas? Let's take a look. Our cow gas is comprised of methane, and remember, 10,000 parts per million is 1%. 10,000 parts per million is 1%. So there's our methane, ethane, propane, butane, normal pentane, hexane, carbon dioxide, isobutane, isopentane, and nitrogen. So we got some C5, C6. Oh, we got some super lights and balanced nitrogen. So the most all of this bottle is nitrogen. Like literally, there's just smidgens of the other stuff in there, and mainly we are just nitrogen in this bottle. So what's going on is we are bringing in our sample, and we're going to go through our SSO, sample shutoff valve. It's going to come up and it's going to T, and it's going to parallel feed both Model 50s. It's going to go in on 1, internally go to 2, fill the sample loop 9 to 10 and out. Same thing there, same thing there. That is literally these guys. So this is your sample coming in, and we're going to parallel feed the sample in on 1. Do you see your number 1? Do you see your number 1? We are parallel feeding the sample in on 1. Internally, we're going to fill it to 2, and then it goes to the sample loop. Sample loop in this case goes behind the valve. But you can see there's your sample loop. It goes from there to there externally. Then internally, we're going to go to 10 and back out. Same thing here, and here's our sample loop. It's a smaller sample loop. That's probably because that's the bigs. The bigs do not need a bigger sample loop. The lights, a little bit bigger sample loop. These are columns for separation. These are our tubes going to our detectors because they got to have the carrier gas pushing our components across our detectors. Carrier gas 3 and 6. Carrier gas 3 and 6. 3 and 6, 3 and 6, 3 and 6 on carrier gas. 3 and 6, 3 and 6, 3 and 6. Carrier gas being helium. Carrier gas being helium. 3 and 6, 3 and 6, 3 and 6. Detector 1, pre-cut. 2, main, 3, backflush, reference. See how they tied the references in together? Because the references, all they ever see is carrier gas. So they can tie those in together. Very cool, very cool, very cool. And then you got your columns. Your pre-cut column, your main column, backflush column, main, pre-cut column, main column, backflush column. So you're going to backflush out of column number 1. On one case, we only want the lights coming through, and then we're going to backflush the heavies. The other one, we're going to let the lights fly through, and then we're going to backflush, I guess, C6. There's our little detectors, our beads on the other side of those goes 30K, 30K, 30K. 30,000 ohms. 30,000 ohms. Okay? Everybody understanding? Everybody got deer in the headlight look? Okay, as long as you got deer in the headlight look. Got our bubbles. All right, here we go. So this is our HMI. We don't need this. We can go to home. There's all kinds of stuff right there. But we are sitting here purging and everything like that. So we'll just go ahead and say run. And we'll give it a second here. And you notice our bubbles, I'll show you that, but our bubbles quit bubbling. Sample shutoff valve made them stop bubbling. Let's say hold. And then I'm going to downsize you. All right, now while we're waiting on this to run, we need to be on application 2. Application 1 is not running, and that's the one we're on right now. As you can see, it's app 1, stream 1. So let's go to application 2. That's the one we're on, and that's the one that's running. So it'll tell you that you're on app 2, stream 1 over here, and that you're running. Okay, so here is where we're looking at app 2, stream 1. We're running. This is your cycle time. We have made it through 64 seconds of 292 second cycle time. Here is app 2. If we want to see app 1, which is in hold, you switch it over to there. There's app 1 in hold, just sitting there doing nothing because we got the door open on her. App 2, that's running. That's the one we're on. That's what's going on. All right, so next thing to look at on that would be our method. What is our method? I can slowly go through this stuff while we're here. Your alarms, of course, it'll pop up and tell you when you have an alarm, and you can do a clear all and everything like that. Here's results from the last runs. You can look at your stream 1. You can look at your last, validation streams, your cow streams. But here's what I'm wanting to work on is your method have to. And main thing right here, let's go to peaks, and then we're going to wait. All right? Because what I want is to wait for this chromatogram to be ready, and then as soon as the chromatogram's ready, we're going to import the chromatogram and then go through our detectors. 10-4, 10-4. All right, here we go. So we got to the end of our cycle, and we are in hold. So I want to go up here, and I want to say chromatogram, and I can say load latest from analyzer because it is the latest run we did, or I can say load from analyzer. And let me show you the difference. Load latest is the most latest chromatogram that we just did, and we got peaks, and they're all not where they're supposed to be because the oven is not as hot as it needs to be, but we do have peaks and everything like that. So that being said, let me go ahead and close this whole thing out, and then let me go back over here and say chromatogram load from analyzer. And in this case, it lets you look at the streams that you're running. And if you had a validation stream that it ran that morning, you could go through here and you could pick out your validation stream that it ran that morning. In this case, we have app2, stream 1, and stream 2. And it's just set up for 2 streams, even though we really only have 1. But, it's for learning purposes. And then the very latest one that ran, okay, so we're looking at 3-16 at 16:19. So that would be the latest one that just ran. And then we would say load. And there again is the exact same thing that we did. Now, we can look at the chromatograms and blow them up right here. But once we've loaded this chromatogram, once we've loaded this guy, we can go directly over to our method and look at it over here, and that's a better place to look at it because then we can make changes and stuff like that. So for instance, so this is RL2, right left 2, and that's got these peaks, the super lights. Okay, so right left is going to be our super lights, right is going to be our heavies. So right is going to have, the C3, C4s, the C5 guys, and then the right left is going to be the ones that are the lights. So let me X this. First thing let's do, let's go to right 1, right left 1. Let's go to right left 1. All right, I chose it. Nothing's here, so you have to come and say show chromatogram. And then there's the chromatogram. All right, so this is your pre-cut, and we are just looking to see where we need to make our cut for our lights. So we're trying to get out certain guys, and we need to zoom in. So you right-click, zoom down, and zoom down. And so there is where our valve switched. And it looks like we're actually on the middle of a peak where our valve switched, which, we probably need to either catch that peak or back flush that peak. And this being nitrogen, that's a big sucker. And then that guy's right after nitrogen, and then that guy. So let's take a look at RL2, which is our main detector. And there is nitrogen. Then there is methane right beside nitrogen. Then we have that guy, and it looks like we back flushed C2. Yep, unless it's not, oven's not warm enough yet. So let me zoom in, right click, zoomy, and yep, methane's there. Then it looks CO2, it looks like, we kind of need CO2 there, and it looks like we back flushed ethane. So we can fix that very easily, and those are our components that we're looking for. There's our windows, and we're not setting windows yet because I think it's going to warm up, and we will get way better with a little bit of warm up. We'll let it run one more time in a second here. We got bubbles. We are purging. Right, left 3 is our back flush detector, and we are definitely back flushing. And we are doing this at time 30, 29.5, so basically, yeah, let me get a little bit better there. Yeah, time 30. And then right 1, pre-cut. It looks like we're letting a bunch of stuff in. We don't even do our valve until like 100 out here, so let's zoom in on that. So let's right click and go down here. And I can see where our valve switches at time 100. It looks like we're getting everybody. So there's our super lights with a C3 probably hanging on the edge of the super lights. And then C4s. C4s together, isobutane, normal butane, and then some C5s, and then back flush. C4s, C5s, back flush. C6 is probably going to wind up having, so here's our main detector. Oh yeah, main detector, super lights, let them fly through. Get your propane off of there. Oh yeah. C3s, C4s, C5s, we back flush C6, so let's go find her on a back flush detector. There she is. She's pretty. She's so pretty. Look at her. But like you can see how our baseline is all jacked up because she hasn't settled down into her temperature of 60 degrees yet. She's, you know, she needs a little bit more time to, you know, zoom out, to line out. And by the way, this is a group. This is a group, and you need to know your group definition on this. So instead of being right here under regular peaks, you would have to go under groups, and then you would have to say RR3, and then we would want to say show chromatogram, and then that brings up your chromatogram, and then you say what time is my group definition, 115 to 150, 115. Yeah, we might want to change that a little bit more to 150 right here. So that's good right there. So, okay, let's give her another run because we're purging. We got bubbles. Let's say run. And hold. While we're waiting a moment for Alright, so while we're waiting a moment for my analyzer to get done running that one sample that we just injected. Whew. Alright, while we're waiting on that sample to get through, let's talk about... Hello? 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 Yes? 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 I am. It's out in Tarkington Prairie, which is near Cleveland, Texas. I'm in Lee College right now in Baytown. I am teaching class right this second. I will be available. I go to work tomorrow at Exxon. We can make arrangements, you know, to go and look at it this weekend. However you want to do it. Okay, and you have cash? Okay. Oh, okay. Well, you read my write-up and everything on mine. Yes. Okay. Well, let's talk about tomorrow. Let me finish up tonight, and as soon as I get off work tomorrow, we can head out there. You want me to mark it as sold? Okay. Yeah. Yes, I'm in class. Yes. I will tell it's sold. Okay. 10-4, sir. We'll do it. Okay, 10-4. Thank you, sir. Very much. Bye-bye. Okay. Okay, boys and girls, here we are back again, and we are in hold, and we will come up to here, and we're going to say chromatogram load latest, and let's see if we're looking any better. Our lines are looking way better. People are starting to kind of get close to where they're supposed to be in their windows. As you can see, they're getting, you know, closer and closer, a little bit more heat, a little bit more time. We're still missing a peak up here, so we probably need to go in there and do some adjusting on that because we're back flushing that peak. Looks like we're, oh, wait a minute, or did we just miss it? Uh-oh. A little bit of heat might have got our ethane in there where it needs to be. Look at that. Look at that. So let's go ahead and take a look at our RL1. And, you know, I think we're chopping a little bit of that off and back flushing a little bit of that peak. So we might want to still scoot that out a little bit because it looks like we are chopping into some of that peak, which we don't want to do. Okay, so if we needed to do that, so what time is this? So it looks like we're doing it at 30. So let's go up here to our cycle events, and then that's valve and DO. And so get this straight. Cycle events, valve and DO. You've got your carriers, and then you've got your valve and DO, which is your valves and timing. It's a digital output. So we're at 30. Let's make that 35. And then let's say method, save to analyzer. Method, save to analyzer. And so we just saved that change that we just did to the analyzer, and now I'm pretty sure we won't be back flushing anything. But whenever we do that, we need to make sure that we change the correct carrier to 35, which this was jacked up anyway, so 35. And those are our pressures, and I'll explain those later. Oh, wait a minute. Yep, we're good. Okay. Method, save to analyzer. We could have done all these changes and then said save to analyzer all at one time, but who's doing this? Now, we're going to go down here, RL2. Those are our peaks we're looking for. Zoom to full. And so nitrogen, that looks good. Methane, you look good. CO2, you don't look good. So if I put my little cursor on the very middle of that peak and then figured out what time that is, which it's 96.034, and so CO2, 96, let's just say 96. And then I'm gonna come over here, and as soon as I hit analyze, see where analyze is? Right there. As soon as I click it, analyze, it jumped over the peak. Oh, there we go. It jumped over the peak. So it's right on top of CO2 now. We're going to do the same thing over here for ethane whenever we get our ethane peak. So here's our ethane peak. And the time for it, 157. We'll just say 157. Up here, 157. And then we're going to say analyze. So remember that analyze is right up here. And as soon as I hit analyze, that jumps over there, and now we have a reading. So that guy moved over. These still are going to keep moving on us a little bit. We'll go over here to the R's. Okay, so that's pretty, that's pretty. Those could be moved over a little bit, but they're going to keep moving. Those could be moved. This guy, he's missing completely, so let's go ahead and give him a 236. So 236. And then analyze. And then he's now reading. This one, it's reading a little bit. So they're okay. They're getting into where they need to be. And then method, save to analyzer, save. All right, we're in hold. We got bubbles going. If we give it one more run, I think then we can calibrate. One more run and then we can calibrate. All right, here we go. Ready? Run. Give it a little bit of time. You notice our bubbles are gone because the sample shutoff valve. And I'm going to throw it in hold. And then we wait. Okay, boys and girls. Okay, so we are at the end of our run. We're in hold. 292 second time. We're on app 2, stream 2. Everything good? All right, so let's go up here. Let's go to our chromatogram. Am I seeing this all? All right, so we're going to go up here. We're going to go to chromatogram, load latest from analyzer. Does everybody see that? Load latest chromatogram from analyzer. All right, so here we go. Load latest. Oh, we didn't give enough time yet. Alright, chromatogram, load latest chromatogram from analyzer. Yes, we gave it enough time. Okay, so here we go. We have right, left, and right, right. So what we're going to want to do First thing, let's do our lights. So let's look at our right, left. Right, left, 1 is this guy. At time -8, we are going to have sample shutoff valve, ARV, and we are going to vent to atmospheric pressure. At time 0, which is that guy right there, that is when we inject. Carrier gas will pull everybody through the sample loop and push them across detector number 1, RL1. We need to see our nitrogen, we need to see our super lights come across there. And after we see them, there's our ethane. Once we see our ethane, then we shut the door and start back flushing everybody heavier than a C2. That is our C2. So that shows me that we got everything and everybody that we want on this side for our super lights. So we will kill this. We will go over to RL1. There it is on here. RL2. Right click, zoom to full. Zoom to full, and then my nitrogen, my ethane, my nitrogen and my methane, I'm happy with. They look fine as far as their retention times and the width of their windows. I am okay with both of those. Very good. Zoom to full. Right click. Zoom to full. These two guys are fine. Everything looks fine on them. CO2 and ethane. CO2 needs to be 91.34. So there, we put the line in the middle of it. You can see where our window is. It is catching the peak, but it's not pretty. We can make it pretty if we go to 91.347. So I'm going to go up here. Come on. .347, and then this guy over here, 148. Analyze. Not bad, but that one's still kind of ugly. Why are you ugly? 91. How did I miss that? 91, analyze. All right, now you're much better. All right. So that's fine. That's fine. We know we're back flushing everybody else. So now it's time to go take a look at our heavies. Right, 2. We know that we caught everybody and that we're back flushing our C6. We can look at it again. We'll go to right, 1. Pre-cut. Looks good. C4, C5s, back flush. Looks good. Main detector. Woo, got to move those. So again, what do we got here? Let's see. We got a 79. 79. We got a 113.3. 113. And we got a 125. And analyze. Hey, pretty. analyze. All right, so now all of our peaks, windows look okay. Let's make that one a little fatter. You see that? IC5. Let's make its width. So if we take that window second right there, let me show you what happens. So IC5 right now is 9 seconds. Let's make it a 20. Alright, and this is analyze. As soon as I hit analyze, make that a 20-second window. As soon as I hit analyze up here, you're going to see what happens on this guy right here. Alright, so here we go. Analyze in now. There we go. Throwing a bigger cast net. Back flush. There's our C6. This is when we're measuring for it. Alright, everybody looks like they need to be where they need to be. We entered our bottle values up in here. And we have to go to show calibration. Did you get that? Where I said show calibration. See, I hit that box right there, show calibration, and it brought up this guy right here. And this guy right here says, for level 1, we're going to put that much in for CO2. You got to go through each one of these peaks and enter your value into the amount, and we're calibrating to level 1. We've already entered all of those, so now all we have to do is hit calibrate. Level 1. And it pops this up. Clear for this level. Yes, because we're only doing one level. Okay. Now every single last one of these are going to go exactly to what we put in there for the bottle. Go back and look at what we put in for our bottle. Go back and look at our bottle earlier in the video. Those numbers are going to be dead on, spot on. Methane, a 1. Those are the numbers. And then, all we got to do is say, method, save to analyzer. Method, save to analyzer, save. Woohoo! That is good for tonight. Yeah.
So you put some new videos together. What do you do? You have it open and everything, you know how to calibrate? Do
Yep.
everything?
Yep. All of it. So,
Cool.
yes, sir. We'll have it ready for them.
Take care, man.
Yes, sir. Okay. We left off yesterday. We were doing some validations, calibrations. We were going to let this sucker line out overnight, let the oven stabilize to the exact temperature that we want. We're showing how we back flushed some of our C2 whenever, so we were back flushing way too early. We showed how to move the valve. That's a digital output, on or off. Valves are on and off. And so today, after everything's been sitting, looking really, really good, we're going to start back up our cow gas. And we're going to get bubbles going over here. And as soon as we have a good sample going through, then we will inject. While we're talking about that, our valve timing is we're going to have a sample shutoff valve, which will go at -8 seconds. We will equalize to atmospheric pressure for 8 seconds, and then we'll inject. Why do we do that? Because gases can be compressed. And we decided a long, long time ago, you know, the people who made this up said that 8 seconds was the magic number. So Yokogawa does 10, Everybody does a little bit different, but how long does it take to equalize atmospheric pressure? That long. Once we equalize the atmospheric pressure, we will inject at time 0, so that turns on the model 50. Carrier coming in on 3 and 6, 3 and 6, 3 and 6, 3 and 6, 3 and 6. We'll sweep the sample loop. That's going from 2 to 10, 2 to 10, 2 to 10. Sample coming in on 1, out on 10, or 2 to 9 is sample loop. In on 1, out on 10, so 2 to 9, 2 to 9, 2 to 9 is the external sample loop. All right, so once we're bringing our samples, so let's go ahead and get our bottle cranked on. Bottle on, and then we need to kick our regulator up. So I'm going to open the needle valve, and then I'm going to turn my regulator up a little until I see the needle barely come up. Okay, and now I got bubbles. Bubbles telling me I have good sample coming in, going through my valves, going through their sample loops. And let's concentrate on just that one right there. So, bringing our sample in, it's going to T, then it's going to come in on 1, come in on 1, so it's coming in on 1 on both of them. Come in on 1 internally because the valve is in the off position. On the off position, we go through these solid lines. We're going to go to 2. We only need to look at one of them. We don't need to look at both. We're going to come in on 1, go through the solid line internally because we're in the off position to 2. Fill the external sample loop, 9. Internally, go to 10, and then we're back out. Circulate, circulate, circulate fresh sample. When time 0 comes about, carrier that's coming in on 3 was going to 4. Now we're going to turn the valve on. Carrier going from 3 now goes to 2. Sweeps the sample loop like a spit wad. Shoots everything over to 9. Then we are going to go to 8. Carrier gas will push our components, all of them, through column number 1, which is a pre-cut column. Pre-cut column will allow the lights to go through, and we will see them first on number 1 thermistor bead. So number 1 is a pre-cut bead. Okay, so then after we get our components of interest, are going to wrap around. They're going to come in on 5. They're going to come in on 5. We're still in the on position. Go to 4. And then the components of interest will make it over to column number 2, which is the main column to be separated out. If they're super lights, they will just fly through and go on to the main detector and not be measured. The components of interest will be separated out and measured. Anybody that we're not wanting to be measured like this, we will back flush when we turn the valve off, and they will come back through column number 1, go to 8 to 7 through that curly Q, which is a restrictor, and then go to detector number 3, which is the back flush. Back flush. All right, so this is this. This is that. That is this. Sample loop. Sample in. Sample out right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Carrier comes in. 3 to 6, 3 to 6, 3 to 6. There's our T. 3 and 6. 3 and 6, 3 and 6, 3 and 6. I'm not going to deal with it. There we go. There we go. So we are purging fresh sample. We are purging fresh sample, purging fresh sample. Let me start over and say again. Whenever we come up to this guy, you're going to have analyzer view, network view. You want to go into your network view. After we go into our network view, we're going to want to see which GC we want to take a look at. In this case, we only have one, but if you're at a normal plant, you're going to have a whole list of them, and then you would choose those, whichever one you're wanting to look at. We're going to take a look at this one, Super 555. We have two apps. Remember, we have two apps. The right-hand side is app 2, the left-hand side is app 1. We are using this app to do our looking at the valves, yada, yada, yada. This side we are actually running. We have two different sets of detectors that we are playing with. We have the right and the right-left. We are using those to do heavies and lights. Heavies and lights. So it's basically two GCs on this app. We are in hold at this point in time. App 2, blah, blah, blah. Now, what we want to do is we want to just go ahead and run. So we're going to get up here, we're going to say run, go. And you notice our bubbles quit going because of sample shutoff valve. Of course, you can't see them right now, but trust me, sample shutoff valve killed our bubbles. And now I'm going to put it in hold because we're going to want to jack with it at the very end. And we will wait. And we shall wait. While we're waiting, I was talking about valves and them doing the movement of everybody through our columns and back flushing, if we wanted to do a heart cut, however we want to do it. This is an ABB slider valve. It works basically the same way as, you know, all these valves have their own little technique for doing. So you see these little cuts that it has? Those cuts is what slides and connects one set of holes to the other, or one set of holes to the other. It's a slider valve. That is ABB's genius way of making our sample go where it wants. Valco valves come with, they're on or they're off, and then they come with a rotor. And inside of here, we're going to have this little guy. And so the inside of there goes back and forth, and that will connect these dots by the rotor. See the cuts on the rotor? Those are precisionally made cuts of a certain quantity, microliters, yada, 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 something along those lines. And they connect up the inside of this, and it's, and those what's will do our flows. Valco. Old style, Model 11s. Internally there's a cushion disc. It slams pins down in between. And that's what blocks flow or allows flow to go. This one has got an internal, already an internal cut for a sample size. And then finally we got a Yoko. This is a Yoko valve. And Yokos, same concept. Yokos put a little disc inside of there with cuts on their disc. and they go, and that makes these line up from one cut to another cut off of the little guy in there. And when you rebuild one of these, if you put it in and you got a smiley face, you've just screwed up. So you can't have the smiley face. It's got to be the opposite direction. When I say smiley face, if you put it in wrong, can you see the smiley face in it? Kind of, maybe, no. Okay. All of them do the same thing. All of these people think that they have the master valve. The master valve, Siemens, Model 50. That suckers, that is bad to the bone. That's the valve. Siemens got that one right. Expensive? Yeah. But yes, the Model 50, that girl right there, she's pretty. She is sexy. Woo! Look at her. Look at her. Okay. All right, boys and girls, we have gotten to the end. There is our cycle time, 292 seconds. We made it all the way to the end. We are in hold. So, we got bubbles going, getting ready for our next inject. We are going to come up here and we're going to say chromatogram, load latest chromatogram from analyzer. Oh, what a pretty baseline on everybody. Oh, I'm liking that, liking that, liking that. Yeah, that's fine. C6, okay. I'm not sure we got a good inject on everybody though, because it looks small. So, let's take a look at you. And you are our RL2. This is our main detector for lights. Here is our R2, which is the main detector for our heavies. So in order to, let's look at RL1 while we're here. And RL1, it looks like we got both of our components that we're needing. Yeah, after our light. So we should have everybody. So let's take a look. Blow up the main detector. Or I'll say. Okay, so there's our bogeys. There's my bogey. Nitrogen, she is sitting real pretty in her window. All right, let's get down here. Right click. And there are our peaks. You, methane, hanging tight exactly where you need to be. You, CO2, are missing. And you, ethane, are missing. So we're going to take our cursor, we're going to put it right over the middle of the peak, and we are looking for its retention time, which that number is right up here, and we're saying 83.8. 83.8. And while we're doing it, let's look at you. 83.8 and 134. 83.8, 134. 83.8, 134. Methods, peaks, RL2, show chromatogram, 83, 8. What did I say? 132? What did I say? Yeah, something like that. So then we're going to come up here and we're going to find analyze. Analyze being right here. Let's see what happens. Analyze. God, I'm good. God, I'm good. Okay. Then we're going to come back down here. Zoom in. Pretty. 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 Nice big wide window, but if we wanted to get crazy with that, and we're at a 12, let's do 20, and a 15, let's do 20, and then we're looking back down here, and I'm going to say analyze. Woo! That's a big cast net. You catch lots of fish. Lots of fish, big cast net. I don't normally do my windows like that, but I'm teaching y'all how to do something. So, you know, I'm gonna put them back to something I like. 12, 12, Analyze. Okay, that's much better to me. That's prettier. You're not completely centered, so we'll get you exactly right there, and that's a 133.78. So 133.78, and then we're gonna say analyze. That's pretty. That's pretty. That's pretty. Everybody's being measured. Everybody's pretty. That is the main detector for you. Main detector for our R2. And that's all the lights that we're letting through as one big peak, not even trying to slow them down, let them go. And then we start getting our C3, C4s, C5s, and then we back flush C6. So here we go. Zoom. C3. $79.5. 79.5. Then we'll come over here. You're pretty good. You're a little off. We'll get you 123.8. 123.8. You need to be 196.3. 196.3, and you need to be a 226. And then we'll say analyze. Oh, everybody's good, everybody's happy, life is good. I see 5, I don't like that window being like that, so we're gonna make you a 12. We're gonna make you a 12. Analyze. Good, 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 good. Let's see our back flush. Back flush in C6, that is a group. Let's see our group definition. So we're gonna come over here to groups. How do we know it's a group? Do you see a line over the top of that, girl? No. Group, RR3. Group definition is 115 to 150, but we can't see anything, so we need to get up here and say, show me chromatogram. Then show me the calibration also. Alright, so we're looking for a 0.15 on the amount. We're looking for 115 to 150 on the group. 115 is right here. That's 115, and 150 is right here. That's good enough for me. I'm okay with that. So now what's left is, let's calibrate. Let's calibrate. So, show up here, show calibration. All the numbers have already been entered. Ethane needs to be a 0.98. CO2, 1.1. And we only have one level, so that's why it's level 1. Methane, we're looking for a 1. Nitrogen, we're looking for a 95. So that's the situation we're at. So let's say calibrate, which is right up here. Level 1 is our level. Clear for this level. Okay. Everybody calibrated, everybody calibrated, everybody calibrated. Don't believe me, you can go look at all the rest of them. They're all calibrated to exactly what's in the bottle and what you said was in there. And then we're going to say method, save to analyzer, and save. Do you want to overwrite? Yeah. And we basically just saved everything that we've done to the analyzer. Now, this is important. System backup unit. This is saving the AMD file. And I want to save it to the desktop. And I want to put the date on it of, what is today? March 17th-20. Alright, so we're going to do that, we're going to do that, we're going to say save. We're saving it to the desktop. Go, go, go. Go, go, go. Go, go, go. Go, go, go. Go, go, gadget arm. Go, go, gadget leg. Go, go, gadget. Backup finish successful. Okay. And we're done with this, but I'll go ahead and say run. And just let it happen one more time. And just show you that it's going to repeat. Sound good? Sound good. All right, boys and girls. Yokogawa GC 8000. I turned you on. You're mad. Acknowledge all. I need you to be in. Come on. So we're going to hit that wrench. And then we're going to hit user level. And we're going to be in C. I'm going to say OK. 1603. OK. User level C. OK. Operator. Heater control. We can't do it from here. It has to be in manual. So we got to go. Let me go over here. I want to open ASET. Doing all kinds of stuff. You is actually who we are having to talk through. So this is PCAS. I'm gonna scoot you down over here and just get you out of the way. And don't know why that jumped up, so we're gonna kill that. That's fine. Okay. Okay. So then I'm going to come over here. And 19 is our analyzer. And I double clicked on it, and then I'll say okay. Uploading. Okay. And then I think I'm gonna hit that guy. And as soon as I hit that guy, it's gonna bring this up over here. And then I wanna hit that guy again. And that brings me up over to here. GC state. Oh, I'm in A, so we need to change this from A. So here's the key. So I had to hit it here. Okay, we're gonna come over here to user level C. Okay, 1603. Execute. Okay. And then downsize U. So we're on C level now, and that gives me this option. And so you see how things are lit up now, and they weren't before? So I'm gonna put it in manual, like that, and then detector status off. Are you sure you want to turn your detector on? Yes. And now my detector is on. And then over here, oven, double click on it. You got to turn on your oven, and you're gonna get to 65 degrees. I hear her kicking on and starting to make purring noises, so we are heading in the right direction. All right, so now we have to wait for oven temp to get to 65. Detector is on. Okay, boys and girls, we were able to get through a cycle, and then it's just kept on running. So if we go up here and we say chromatogram, load latest chromatogram from analyzer, and let's just blow that sucker up. And this is, of course, the pre-cut and we don't need that. So if we kill that one, it makes everybody else bigger. There's a back flush that we're not measuring anything on, so we can kill that. Pre-cut for RR1, we know that we're set right. Get rid of that. And then we have left our back flush where our C6. That's beautiful. That's beautiful. Nice back flush measuring that peak. Get rid of that. And that leaves us with our two main detectors of RR2, RL2, where in this case we are going to measure our light, measure this methane, which is a light, CO2 a light, and ethane, C2, which is a light, and then back flush everybody heavier. Who's heavier? C3, C4s, C5s, and then that C6 that was measured on the back flush. Now what do we do with our super lights on the bigs? We let the super lights fly through. Don't do anything with them, just let them fly through, and then separate out the bigs. How are we looking? Nitrogen is supposed to be a 95. 94.96. I don't want to say good enough for the girls I go out with because I'm going out with a badass, but anyway. Methane. 1. CO2, 1.11. And then ethane, 0.98. Propane, we ran a 1. Let's zoom in on the C4s. 0.98. 1. Right click, zoom to full. And then our C5s over here. 0.32, 0.30. I would say we're kicking ass and taking names. And then we just inject it again. This one is done. Dominus, ominous, good. Killed. And there is our AMD file that we saved. Well, boys and girls, here we go. That valve is that valve. That valve is that valve. It's a dual-sided valve. One single action will do both sides. Same thing as the other stuff. Solid lines, we are in the off position. Dotted lines, on. Carrier, see it coming in on 51. I will explain all of this. Okay, so whenever we are doing a calculation to do a response factor, which is the way I'm teaching everyone to do the Yokogawas, is we are going to do current result times our current response factor, which in this case Yokogawa calls it area. So result times response factor divided by bottle or lab, however you want to look at it. So if we hook the bottle up to it, in this case we are going to be doing oxygen nitrogen. So the air we are breathing is 21% oxygen, but we're going to use 20.9 and 79 for our nitrogen. All right, so that is our bottle, that is our lab. Let's go see what our current response factor is. at 65 degrees. We have to take her out of manual or she's not going to run right. So we got to take her out of that. So what we got to do is say GC state process. All right, so we are in process now. See how everybody lit up? See how everybody's lighting up like they should? And we're at 65.1 on our temperature. Detector is on. And we are going to go ahead and get her going. And that way we get some peaks coming. And she went to a minus 120. Okay, minus 120 seconds. So she's purging our sample. Purging our sample. All right, now, set up peak. And in order to calibrate, you have to be on the calibration stream. Stream number 1 is a process stream. Stream number 2 will give you our cal stuff. So stream number 1 is blanked out. Nothing's over there. But if we come up here and we go to stream number 2, for peak number 1, standard concentration is 20.9, standard area 102,840. 102,840. And then that's peak number 1. Peak number 2 is going to be our nitrogen with a 78 concentration, and it's 1528, and I'm not putting 0.04, 1528. Okay, so we got the information we needed. I'm going to exit this, and we are running our chromatogram. And if we want to see a good chromatogram, let's go up to here, and then let's choose the chromatogram. And then we will watch and see everything coming along. There's our time clock for our cycle time. We're getting a peak. There's our gate right there. And we made these time gates. We could have done slope gates, but I think we chose time gates on this instead of slope gates. And then there's the off gate. And there's an on gate. And then there's our peak. And we probably need to move that a little bit. How do we see our tick marks for our timing? Let's see, how do we do that? So we come over here and last chrome, previous chrome. So we're going to overlay, okay. And then timing mark, blah, 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 okay. Pin select, okay. Okay. There's where we're doing. Gate on, off. That's the ones we're choosing. We could do the peak on and off also. Okay. So there's our chromatogram going along. We started over. So this is coming through here. We need to see some results. So let's go up here to our beaker. And then I want to say auto. So I chose auto with the beaker. And we were calibrated to 50-50. That's what I made the class do. There's our start time, retention time, end time, blah, blah, blah. we're calibrated to 50-50. In this case, oxygen's 51, nitrogen's 50. Okay, so we're just going to say 51-51. 51-51 to make the math easy. Okay, here we go. We are saying our current result is 51 and 50.66. That's what we'll do, 51 and 50.66. So if we say our current result of 51, we're going to multiply that by the response factor of 102.84 equals, divided by our standard 20.9, that's going to give us a 250. We're going to say 251. Current result, 50.66. Come on. Result, response factor times 1528 equals, divided by 79, 970.98. This will calibrate that analyzer. All right, so let's get rid of our results for right this second. Are you sure to close? Yeah, we don't want to close it. Let's just downsize it. All right, and then let's go to, let's downsize our chromatogram. And then let's go to U, and let's go to setup, let's go to peak, and we need to be on 2. So stream 2, peak number 1. And we said our standard area is going to be, what did we say? 251? So let's say 251. Change. Yes. And okay. And then we're going to say peak number 2. And we're going to say 980. Change. Okay. And exit. And then we'll go back up here and let's find our chromatogram. And you see how it's drawing a line over? So it's repeating, like perfectly repeating. And gates are exactly where they were before. We are absolutely drawing lines over lines, so it's absolutely repeating. And then we want to go back over here and we want to say results. Where's my results? There's my analysis results. And then I want to say auto. Do I gotta wait till the end? I don't want to save. Okay. It made me wait until we got to the very end for it to do its calculation. Once it did its calculation, I hit auto. Once I hit auto, then we came up with 19.6 and 74.29. So we can sit here and play with this and do the math and get it exactly dead on for our calibration, but that is how you would calibrate. If we wanted to move our gates, I'm closing that. And let's say we wanted to move our gates a little bit. So this gate right here, that gate's fine, that gate's fine. We want to scoot that gate back a little bit. So that's peak number 2. So let's go set up peak, gate on, gate off, but we're wanting peak number 2. No, peak number 2. Gate on time, let's make it 90. Change. Okay. And then let's go back to a chromatogram. And we are currently drawing right over the other one. We'll wait for the next one. All right. I'm going to change you to 87. Change. Okay. Because gate number 1 off is 85. Exit. $85, $87. There's time gate. We have the option of slope gating. Exit. Finishing that up. All right, one more time. And we should see that gate move. That gate. There's the gate move. There's my gate move. Thank you. So we moved the gate.